Hello and welcome. I hope you guys are all having a great reInvent. My name is Chanu Damarla, and I'm the Principal Product Manager for AWS Lake Formation. And in this session, we will talk about data lakes and how Lake Formation helps you easily build, secure, and share data across your entire organization. We will start with an overview of why our customers are building data lakes, review some of the challenges that they have building these data lakes, introduce Lake Formation and how Lake Formation solves for these challenges. And then we will have our guest speakers and friends from JP Morgan Chase speak. First, we'll have J.R. Reed, who's the Chief Information Officer for the Employee Experience and Corporate Technology line of business, speak about why JP Morgan Chase chose to build their data mesh architecture using Lake Formation. And then we will have Anu Jain, who's the Managing Director of the Consumer and Community Banking line of business, speak about how JP Morgan built their data mesh architecture using Lake Formation. Let's dive right in and talk about why customers are building data lakes. Well, the simple answer is that customers are building data lakes because they want more value from their data. The data volumes that they have to handle are growing exponentially, from terabytes of data to petabytes of data, and in some cases, to exabytes of data. In addition, they're increasingly working with more diverse data sets, like logs from production database systems or production web systems, real-time streams from IoT devices, voice recordings from their call centers, or videos from media sites, social media sites. And finally, we're seeing that customers want to enable more and more people inside their organizations to use the data. And in addition, we're increasingly seeing applications automatically using data to make decisions on behalf of the organization. For example, an application may automatically order new supplies when the inventory in a store drops below a certain threshold. Traditional on-premise solutions aren't able to handle these data volumes because they don't scale well enough and are too expensive. To handle the increasing data volumes and variety, customers are increasingly building modern data lakes to break down the data silos inside their organizations. To do this, many companies are taking all the data from the various silos and aggregating it in data lakes so that it can enable analytics and machine learning workloads. They're also leveraging purpose-built engines like a data warehouse to quickly get results for complex queries on structured data, or in a search service to be able to analyze log data quickly and effectively. For example, to monitor the health of production systems. These modern data architectures are built around scalable and secure data lakes. Data lakes are the new information hub. They provide a flexible, secure repository that enables you to store, govern, discover, share, and analyze structured and unstructured data at any scale using the tool of your choice. Our customers appreciate the flexibility that data lakes provides. By keeping their data in open formats and using standards-based applications, our customers are able to ensure that their users can always use the right tool for their job. These tools process the data in place, so you don't have to move data into these engines. You're not creating another walled garden that you need to migrate data into. You keep your data in your data lake, and the tools work on the data in place. It is important to remember that customers are building data lakes to break down their data silos. And so a data lake is not the new monolith. In fact, our most advanced customers have multiple data lakes across multiple accounts inside their organization. They understand that their architecture has to reflect the realities of how data is generated, processed, and shared across the organization, and in some cases, even across organizations, like with their vendors or with their customers. These customers are building a data mesh that enables the governed sharing of data products across one or more data lakes. For example, the web team inside your organization may be responsible for processing log data and creating curated data sets that they share with other lines of businesses inside your organization, like the marketing team or the engineering team. And these other lines of businesses may create and share curated data products of their own across the organization. Now, of course, all of the sharing has to be governed in order to ensure that your organization complies with applicable regulations. There are more data lakes and analytics on AWS than anywhere else. In fact, we have hundreds of thousands of data lakes across all industries and organizations of all sizes. And while the benefits of data lakes are clear, there are several challenges with building and securing data lakes that I want to talk about now. In working backwards with our customers, we've identified 5 key challenges that they all kind of walk through. These challenges are: first, building reliable data ingestion pipelines is complex. Second, managing how data is stored and optimized in S3 can be time-consuming. Third, managing permissions at scale is difficult and error-prone. Fourth, integrating the service or application of your choice can be hard and in some cases even impossible. And fifth, sharing data across accounts inside your organization is cumbersome. We will dig into each of these challenges and how lake formation helps address these challenges in the rest of this talk. But needless to say, because of these challenges, building and securing data lakes can still take months. And that's why we built Lake Formation. Lake Formation is our fully managed service to help you build data lakes quickly. It simplifies security management with centrally defined security, governance, and auditing policies, and it provides self-service access to data so your users are always able to get the most out of the data in your organization. Since launch in 2019, Lake Formation has been adopted by thousands of customers who are managing petabytes of data with it. These customers chose Lake Formation because it helps them resolve some of the key challenges with building, securing, and managing data lakes at scale. Let's start by reviewing how Lake Formation can help simplify your data ingestion and management pipelines. To do this, we first need to understand why data ingestion and management is hard. It's hard for 3 reasons. First, the data in your data lakes is constantly being updated, whether this was because you're ingesting streaming data or change data capture records from production databases. The data in data lakes is being refreshed constantly. So ingesting this data while simultaneously providing a fresh version of this data to your business users so they can query it is a challenge for data engineers. Second, data is often stored in your data lake or in S3 in the form in which it arrives. So if you're ingesting streaming data, you might have lots and lots of small files in your data lake. Or if you're migrating an on-premise database system into your data lake, you might have a few very large files in your data lake. But neither of these layouts and forms is optimal for sort of consistent and fast query performance. And third, customers are required to build complex systems to protect consumer data and comply with GDPR, CCPA, and other regulations. In the case of complying with right-to-be-forgotten rules and requests, customers must find individual records or rows in vast number of opaque S3 objects in order to delete them. And this is a complex process that delays complying with these requests while at the same time risking large fines. To address these challenges, we built governed tables. Governed tables are a new type of table in S3, and they support ACID transactions with simple start, commit, and rollback semantics, similar to what you'll find in database systems. With governed tables, it's simple to build reliable data ingestion pipelines that continually ingest data and update the data in your data lakes while it is simultaneously being queried, and recovering from errors is simple with transaction rollbacks. When you use governed tables, lake formation will monitor and automatically optimize how the data associated with governed tables is laid out in S3, so query times are always fast and consistent. Finally, governed tables support time travel, so it's possible to query your data lake as of a specific point in time in the past. This is useful for reproducing experiments or auditing and understanding what data changed inside your data lake and how that data changed. Governed tables are reliable, performant, and versioned. Let's dig into how they work. To understand how governed tables work, we first need to review how traditional S3-based Apache Hive-style tables work. What you do is take all the rows in your table and you put them in S3 objects and store those S3 objects in partitions. From a mental model perspective, you can think about it as taking the rows in your table, putting it in files, and putting those files in a file system or a directory of files. The metadata associated with the table is the list of all the S3 objects and the partitions in which those objects reside. And this metadata is typically managed in a data catalog, for example, the Glue data catalog, or via manifest files in S3 itself. For governed tables, lake formation manages the manifests or the metadata associated with these tables. The data continues to reside in S3 in your accounts. Lake formation is simply managing the metadata associated with these tables. And this means that importing and exporting from governed tables is a fast and simple operation because it's a metadata-only operation. The data continues to reside in place in your accounts in the formats you selected. Governed tables support two different APIs for accessing and updating them. First, we have manifest APIs that allow you to transactionally add and remove files from governed tables. So in this case, you have a transaction 2, that's adding 3 files to the governed table, the files in orange. Now these transactions can run concurrently, and lake formation will order them for you. So in this case, you have another transaction 3, that's adding 2 files to the table, and it came after transaction 2. We also will provide row-based transactional APIs that will allow you to insert, update, and delete rows into tables. The way this works is that you have your base data stored in the larger files, and then deltas or updates to those files stored in the smaller files. And when you want to read from the table, lake formation will retrieve these records and reconcile all the updates, resolve all the changes, and give you back a consistent view of the rows inside your table. The data structures associated with maintaining governed tables are actually pretty efficient, so being able to go back in time to a previous instant to support time travel is instant. And I'm happy to announce the general availability of manifest-based APIs for governed tables with initial support in Athena, Glue, and Redshift Spectrum. Let's see how governed tables can help you simplify your data ingestion and management pipelines. Imagine you have an ETL process that periodically, say every 10 minutes or so, processes CloudTrail data and partitions and stores it on S3. Now, this process may fail sometimes, as ETL processes do. You also have users that will query the data in an ad hoc manner. This means we can't always know when they're going to query the data. Let's look at a couple of scenarios to see where the complexity of ingesting and querying data at the exact same time resides. Okay, you have an ETL process that runs, and it's in the process of adding some files into the table. If your query runs at this time, it's not running at the same time that your ETL process is running, so it's going to run correctly. It's going to see 8 files associated with the table, and it's going to run correctly. But let's consider another scenario. The ETL process is running, and it's in the process of adding 4 files to your table. While this ETL process is running, a query is going to start executing. In this particular case, this query is going to see an inconsistent view of the data. In fact, what files will it see? Will it see 8 files? Will it see 9 files? Or all 12 files? It's inconsistent. We don't know. And in fact, if the query is running for long enough, it might actually see different versions of the set of files associated with that table while it's actually executing. Let's take a look at another scenario. The ETL process runs. It wants to add 8 files to the table, but there's an error, and some of these files have errors in them. And as a result, the ETL process stops execution, and an engineer is called to try to fix this ETL process. If a query runs at this particular moment in time, this query will now see an erroneous view of the data because it will see the files from the failed ETL job. Eventually, someone will come in, remove the files from the table, rerun the ETL process, and fix it. Now let's look at how transactions can help. If the ETL process uses governed table transactions to ingest the data, it's going to open a transaction before it adds the files and then commit the transaction at the end. This query ran correctly before, it will continue to run correctly now. But this query will now run correctly because what's going to happen is that this query is going to see an isolated and consistent view of the table from before the start of the transaction associated with this ETL process. Okay? In the case of an ETL process error, the ETL process will simply roll back the transaction. Those files will no longer be associated with the table. And now when this query runs, this query will also run correctly. Because the transaction has already rolled back the erroneous files. So you'll no longer have an issue with the erroneous files being visible to this particular query. Now, let's run this forward for a little bit of time, right? You run this process, this ETL process is running for months and months at a time. And eventually, it'll get to the point when your query may start having poor performance because this query has to process a lot of really small files. And this is where governed table storage optimization comes in. With storage optimization, governed tables will automatically compact small files into appropriately sized files to improve analytic engine performance via small file compaction. So your query times are always going to be fast and consistent. The benefits of small file compaction are significant. You know, in the previous example, just to make the pictures look pretty, I showed 5 files being converted or compacted into a larger file. But in reality, the compaction is taking place over thousands and thousands of small files that are merged into each one of these compacted files. These screenshots show a table that consists of ingested CloudTrail events. Before compaction, the small files are on the order of 2.9 to 3.1 kilobytes. And you can see that the compacted files are on the order of 38 to 40 megabytes. That means each of those compacted files actually represents 1,000 to 1,250 of the smaller files. And the impact on query performance is actually quite significant. A query that ran on the compacted version of the data took 20 seconds versus over 2 minutes and 14 seconds on the uncompacted version of the data, an order of magnitude performance. Okay? We mentioned before that governed tables are versions, so they support time travel. To use time travel, simply use the new as of time SQL clause. When you use this as of time phrase, Lake Formation will find the closest version of the table from right before or equal to that timestamp and will run the query versus that version of the table. Some customers that are using transactions to simplify the development of their data ingestion and management pipelines include Huddle and Powered By, and they appreciate how governed table transactions help them produce trustworthy data and release new products quicker. Okay, so we've spoken about 2 of the 5 challenges, how Lake Formation can help you manage or simplify your data ingestion and management pipelines. Now, let's look at how Lake Formation can help simplify managing permissions across your data lake and integrating it with the application or service of your choice. Again, in order to understand how Lake Formation can help you, we first need to understand what the problem is. So why is managing data lake permissions hard? Well, the first reason that managing data lake permissions is hard is that when we built the data lake, what we did is we disaggregated the traditional components of a database, and by splitting up storage into S3, metadata into a data catalog like the Glue data catalog, and compute into specific engines like Athena, Glue ETL, SageMaker, EMR, and so forth. And each of these systems has its different permissioning mechanism. So for example, to manage permissions in S3, you were writing resource policies. To manage permissions on the Glue data catalog, you were writing IAM policies. And to manage permissions in an analytic engine, you are first integrating that analytic engine with the data catalog of your choice, and then managing IAM policies for what an individual user could do inside that permission. Keeping the permissions in sync across the entire data lake stack is an error-prone and difficult process. The second reason that managing data lake permissions is difficult is that you need to be able to configure fine-grained permissions that restrict access to specific portions of the data. So users only have access to the specific portion of the data that they're supposed to have access to. Remember, we broke down a data silo by bringing all the data into a data lake. But individual users that are accessing this data lake should only have access to very small portions of this data. So you need to be able to slice and dice the data inside your data lake and make sure you have a mechanism for configuring those permissions to specific users. Now, this may be possible if you had a few resources and a few users, but you have to do this and manage these permissions at data lake scale. That means typically on the order of thousands of data catalog resources, like databases and tables that you're managing permissions for, going into tens of thousands, and tens of thousands of users, going into even sometimes hundreds of thousands of users. And the third reason that managing data lake permissions is difficult is that on the one hand, we're trying to democratize access to the data. But on the other hand, we need to make sure that this access complies with your rules and regulations. You need to be able to monitor and audit data access to ensure compliance with your regulatory and governance requirements. But where do you start? And more importantly, how do you stitch the trail from a query in Athena, which led to an API call to access the Glue data catalog for a specific table, which in turn led to the read of an actual S3 bucket? Simplifying data lake permissions and solving these problems is one of the core benefits of Lake Formation. And Lake Formation does this by providing a new authorization model which runs on top of the Glue data catalog that supports database-style, fine-grained permissions on data catalog resources. These permissions apply across the entire data lake stack. This means that Lake Formation will help you manage S3 access in addition to data catalog access. And these permissions work with a variety of integrated analytic and machine learning services. To scale managing permissions in Lake Formation provides Lake Formation tag-based access control. And finally, because all access is being authorized through Lake Formation, you now have a central place to monitor access inside your data lake. Let's dig into each of these items. First, Lake Formation supports database-style grant, revoke permissions on data catalog resources. Just like in a database, you grant users access to resources, you can use Lake Formation to grant principals access to specific resources. Principals in this case are IAM users, IAM roles, SAML users, and SAML groups. You can grant these people or these principals access to resources. Resources are the catalog itself, databases within the catalog, tables within databases, and then portions of a database, portions of a table, columns, or rows and cells inside the column using data filters. The permissions that you can give are based on the resource you're granting the capabilities or the permissions on. So for example, on tables, you can grant principals metadata permissions like describe table, alter table, drop table, or data permissions like the ability to insert data into a table, delete data from a table, or select the data inside of a table. Lake Formation supports delegated permissions management using the grantable option. This means that if I grant you select capabilities on a specific table, you can then, with the grantable option, then you can then grant other people inside your, for example, group, select capabilities on that table as well. So it simplifies permissions management inside your organization because you, instead of having to grant permissions to every single user in your organization, can delegate or grant permissions with the grantable option to individual administrators in your group. A final point about Lake Formation permissions is that Lake Formation permissions are additive. This means that the effective permissions for an individual is the union of all the grants that that user received. Working with this permissioning model should be natural to anyone familiar with database permissions, and setting up these permissions is simple. First, specify the principals you want to grant permissions to, specify the resources you want to grant permissions on, and then specify the exact set of permissions you want to give those principals on those resources. Now this is a pretty simple example because it's giving Chanu and Mert access to the entire table. But, and this is the really important part, Lake Formation lets you give access to specific portions of a table to users. Let's see how that works. Since launch, we supported column-based permissions. This meant that you could restrict the set of columns that you were granting access to. You could do this by using an include list, which basically said this user is going to get access to these specific columns, or by providing an exclude list. Give Chanu access to the entire table, but restrict access to specific columns, for example, personally identifiable information that contains date of birth or social security numbers. With this reinvent, we're pleased to announce the general availability of Lake Formation row and cell level permissions with initial support inside Glue, Athena, and Redshift Spectrum. With row-based permissions, you can restrict the set of rows that a user has access to, and you define that set of rows using a particule expression. For example, region equals New York City, or hospital equals Bellevue Hospital. And cell-based permissions combine column and row level filters to further restrict access. To use row and cell level permissions, you create a data filter. That's also simple. Let's take a look at how that works. Again, like before, you specify the principals you want to give permissions on. You specify the resources that you want to give permissions on. And now, for that particular table, we're going to create a data filter. Click on Create New, and you'll see a dialog box that lets you define the column level access that you want this data filter to support, as well as the set of rows that you want those column level permissions applied to. Once you create new or create filter, this filter will be created and it will automatically modify or it'll restrict access to the specific cells, the columns, and the rows associated with this particular filter. Now you specify the exact permissions you want to give your users. In this case, we're only granting the select permission. Now, if you have to set up these permissions, for every single user on every single resource, it will get a little tedious. And so, to simplify managing lake formation permissions at scale, we launched Lake Formation Tag-Based Access Control. Using lake formation tags is pretty easy. First, you define your tags and the values that those tags can take. You can also restrict which users inside your organization are able to tag data catalog resources with specific tags and specific tag values. Second, you tag or assign lake formation tags to resources. Lake formation tags are hierarchical. This means when you define, for example, or associate a tag with a database, all the tables inside that database will inherit that tag. But these tags may be overridden. So in this case, the table is being granted a particular tag, and all the columns will inherit that tag, and you can, of course, override the tags at an individual column level. Once you've tagged or associated lake formation tags with all of your resources, simply create policies on these lake formation tags. And setting up permissions based on lake formation tags is simple and similar to setting up permissions on data catalog resources. Let's take a look. Like before, specify the principals that you want to grant permissions on. And instead of now name data catalog resources, select resources matched by lake formation tags and the specific tag values you want to grant permissions to, and then specify the exact permissions. What's different here, you'll notice, is that you're granting different types of permissions because you can have databases that are tagged that are associated with a specific tag, as well as tables that are associated with a specific tag. And so what you're doing is you're defining database permissions. What permissions do you want this user to get on databases that are tagged with those values, as well as table level permissions. What permissions do you want this user to get on tables that are tagged with these specific values? Okay. So far, we've reviewed the lake formation permissioning model and how lake formation tag-based access control can help you manage these permissions at scale. But what about the underlying S3 permissions? Right? We mentioned before that lake formation is going to unify permissions across your data lake stack. It does this via a technique called credential vending. And that means that you no longer need to manage and keep data catalog and S3 permissions in sync. To do this, you register data locations with lake formation. And what that does is it authorizes lake formation to vend temporary credentials or give temporary credentials to analytic engines so that they can access data on behalf of users. Let's take a look at a sample query to see how this works together. Okay. An administrator sets up permissions on data catalog resources and registers the locations where those resources reside. When a user submits a query via an integrated service, the service will first will check that the user has authorization to access the underlying tables. It will then retrieve temporary credentials from lake formation to access S3 on behalf of the user. It will access and retrieve the data from S3, and then it will execute its query or execute the computation required. And this is the important part. It will enforce lake formation permissions. The service is filtering the data, dropping columns, filtering specific rows, before returning the data to the end user. The key thing to notice is that the service has to be trusted to enforce lake formation permissions. And trusting services to enforce lake formation permissions securely may not be possible in all cases. For example, you want to build a custom application, but you don't want the owner of that customer application to be able to get access to the underlying S3 credentials and bypass enforcement of those policies by accessing S3 directly using those credentials. And so to simplify integrating with lake formation permissions for third-party services and simplify building custom applications that use and can integrate with lake formation, we introduced the Lake Formation Storage API. These APIs sit between the analytic engine and Lake Formation and S3 and consistently enforce Lake Formation permissions and return consistent views of governed tables to analytic engines. Let's take a look at what this query looks like. The administrator sets up Lake Formation permissions on data catalog resources and registers the S3 locations where the data for those resources resides. When a user submits a query, the integrated engine will try to read the data through the Lake Formation storage API. The Lake Formation storage in the API will authorize access, retrieve credentials to access S3, read the S3 data, and filter the S3 data before returning this filtered data back to the engine, which will then complete the computation and return the results to the end user. And the best part is, regardless of which integration option services pick, all access to data and metadata is being authorized via Lake Formation. And this enables centralized auditing and real-time monitoring to ensure compliance with your regulatory obligations. All events are logged in CloudTrail, and it's possible to set up CloudWatch to ingest CloudTrail and use CloudWatch events to take action in case abnormal activity is detected. So it's simple to integrate Lake Formation into your existing auditing and monitoring systems. Customers like Macromill, a leading marketing research company in Japan, and FanDuel, an online gaming site, are using Lake Formation to secure the highly confidential and personally identifiable data in their data lakes. And they appreciate how easy and simple it is to restrict and set up these fine-grained permissions. Okay, we solved 4 of our challenges. Let's talk about the 5th challenge. How does Lake Formation help you share data across the accounts inside your organization? And how does it help you share data even across organizations? To see how Lake Formation helps, again, we first need to understand why it was hard to begin with. And so the traditional way of sharing data across accounts was that you were setting up cross-account S3 and IAM policies. Now, these policies had limited service support, but perhaps more problematic, they lacked discoverability. Because these policies were set up on the producer account. So as a consumer, a user of the data in the consumer account, you actually did not know what data sets or data resources you had access to. In addition, policy size limits meant that sometimes customers were setting up overly permissive cross-account sharing policies. Now, if you didn't want to manage cross-account S3 and IAM permissions, then you were basically creating multiple redacted copies of the data sets and then copying those data sets into the consumer accounts using ETL pipelines that were expensive, brittle, and error-prone. Lake Formation simplifies cross-account data sharing. And we did it by basically extending the permissions model to enable the sharing of data across accounts. A producer account grants permissions to an account the exact same way that you would grant permissions to an individual user. And in the background, Lake Formation sets up all the cross-account policies and manages them for you, and these shared resources are now available and discoverable in the data catalog on the consumer side. Now, if the producer used the grantable option when granting these permissions, then the consumer's account's data lake administrator would be able to grant further permissions to the users inside the consumer account. The consumer then creates resource links, and analytic engines use these resource links to access the data. From the perspective of an analytic engine, accessing a resource link to one of these shared resources looks exactly the same as accessing a data catalog resource inside the consumer account. What's different is that Lake Formation will seamlessly proxy that request to the producer account's data catalog and return the latest up-to-date information for calls like get table or get partitions. and sharing data across accounts is simple. Like always, specify the principals you want to grant permissions to. In this case, it's an account, an organizational unit, or your entire organization. Specify the resources you want to grant permissions on, and then specify the exact set of permissions. Be sure and use the grantable option so the data lake administrator in the receiving account will be able to further grant permissions to other users. Okay. Customers like GoDaddy and D2C and NTT Docomo Company are using Lake Formation to share data across their entire organizations. And using the cross-account capabilities, our customers have built many different data sharing architectures, including a data mesh architecture. And now, I'd like to introduce you to J.R. Reed, who will talk about why JPMC built a data mesh architecture and why they selected Lake Formation to help them on this journey. J.R.?
Thank you. Shanu, thank you for that great overview of Lake Formation and why data lakes and challenges with building data lakes. So for the next 15 to 20 minutes, myself and my colleague, Anu Jain, are going to walk you through why we chose Lake Formation and how we built a data mesh architecture using data as products using Lake Formation. And this is our data journey into the cloud. We're learning by doing. And we'll evolve and we'll get better. So it's a journey. As I get started, just wanted you to have something, keep something in mind as we share this journey. A quote, something that I read, can't remember where the quote came from. It says, learning is creation, not consumption. Knowledge is not something a learner absorbs. It's something that a learner creates. So with that, let me share a little bit more about how JP Morgan Chase is delivering at a global scale. 1, 50% of US households have a relationship with JP Morgan Chase. Over 80% of Fortune 500 companies do business with us. We have a very large presence in the markets globally. With that gives us $31 trillion in assets and operations worldwide. We process more than $8 trillion in payments. Now, what's awesome about this, underpinning all of that, we have over 50,000 awesome technologists, UX designers, data scientists, architects, product owners, product managers that are maintaining, building, designing over 6,500 applications, products, and services. We have over 250 virtual workspaces, and ultimately, because of this global scale, we have 450 petabytes of data. Why is that important? Because data is a critical economic asset. It enables companies to achieve competitive advantage by enabling them to drive profitability and enabling their digital business models. So it was important for us as we started to think about our journey into the cloud and how we're going to modernize ourselves in the cloud, how we're going to move our data into the cloud to unlock the opportunity and the business value that's in that data. But we didn't want to build a traditional data lake, the monolithic physical data lake. We wanted to build a logical data lake based on a data mesh architecture and using data as products. Now, to unlock the opportunity and the business value, it's important that we wanted to smooth the flow of data as we land that data in the cloud. So that includes 1, democratizing our data, accelerating the ability to get access to that data. It exists and is readily available, and minimizing any bottlenecks. 2, putting that data to action, which requires data speed. That's your ability to acquire, store, clean, and curate very rapidly and create meaning with that data So now it can be used for analytical purposes and you can derive insights from it. And then lastly, and more importantly, governance and control. But more specifically, automating the governance and control. We want governance and control, but we want to make sure we're not impacting our data speed, while at the same time making sure that we have the right controls in place as we democratize that data. Now, keep in mind, we deliver at a global scale. So we got to do all of this at scale. Scale includes the size of the data. It includes data source proliferation. So that's many origins of data and being able to connect to the data where it's at. And it also includes diversity of data. We want to be able to go beyond our organizational boundaries, our line of businesses, and connect the data so we actually can achieve the opportunity and the business value that's in that data. Now, to do that, you gotta think holistically and how you're gonna build this modern architecture in the cloud. These are the imperatives. These imperatives are very important as we think about modernizing our data platform. Cost savings, business value, and data sharing. In all my years, data sharing is an afterthought. Everyone thinks cost savings and business value. But you don't want data to be an afterthought. Data sharing. You want to match, with data sharing, you want to match the business needs to the data domains. You want to reduce the copying, improve ownership, accountability, and the data quality. Now, to achieve these three pillars, I'm going to give you an analogy. When going into the cloud, you got to think like a city planner because you're building a city in the cloud. Think about what a city planner does. City planner looks at his or her resources and thinks about how efficiently to use those resources to build that city in the cloud. Where to put buildings, where to put roads, where to put traffic lights. Most importantly, how to treat the most precious resource, which is the flow of water into that city. Well, guess what? Your data is that water supply into your city that you're building into the cloud. Imagine building a city and forgetting to put the pipelines in, and now you got to go back and reconstruct that city. It's not cost effective. So you want data to not to be an afterthought. You want it to be planned day one in the cloud. I've seen many companies go for the first two pillars, they get some value, then they realize they can unlock other value with data, but they have to re-architect what they put out in the cloud. Very costly and time consuming. So the way we thought about it, we wanted to stop the proliferation of data puddles. Think of data puddles as single-purposely specialized built data stores. Shift those data puddles to data ponds. Think of data ponds as well-defined data domains, AKA data products, and have those data products or data ponds contribute to a logical lake. Not a physical lake, a logical lake. And it's this logical lake that creates this data mesh architecture that gives you a loosely coupled distributed data architecture. Think of it as your microservices architecture of data. And that becomes the sufficient data supply system, just like the water supply system to your city, that becomes your supply system to your city that's in the cloud. Now, when you think about this data mesh architecture, Chanu touched on a lot of things here, but I'm just going to highlight a couple of things. One, the reason why we chose lake formation, as you can see in the picture there, each data product is a separate AWS account. Loosely coupled, allows us to create data ownership. You build it, you own it, you run it. But what's key with any data mesh architecture is the self-service data infrastructure services, if you know about a data mesh architecture. And the litmus test to that self-serve data infrastructure services is the ability to reduce the lead time to create your data products. That's giving you the ability to have ingestion, cataloging the data, entitling the data, making it easily accessible. This is what Lake Formation does. And the beauty of Lake Formation, not only does it do it at an organizational level, remember, we're global scale. We need to do this across multiple LOBs. And with Lake Formation, we're able to rapidly get that in place. In all my years in building data lakes, even in the cloud, the hardest piece was the fine-grained entitlements. When Lake Formation came along, light bulb went off. We can move much quicker in the cloud and scale into the cloud because Lake Formation has provided the ability to do fine-grained entitlements. Lastly, I would touch on is the hybrid option you see there. We're on this journey. With a data mesh architecture, you now have the ability to be able to mimic as close as possible having data products on premise. With data products on premise, data products in the cloud, with Lake Formation, the ability then to use Redshift Spectrum, connected with some other open source technology, you can federate SQL queries, and now you have the ability to span across multiple clouds, your public and your private, because you know what? This journey takes time. You're not going to get all your data in the cloud day one. So with that, the last thing I want you to think about is product thinking. This was the hardest part of the journey, shifting to thinking with data as products. It's a cultural transformation change. It's not technology. What we learned, it took us 2 to 3 months just to establish and align on common taxonomy and terminology for data as products. What's a data owner? What's a product owner? What's the relationship between those two? Do multiple data owners contribute to a product? Data engineer, who's the technical owner? Then we wanted to align the needs of the consumers with what I call roughly right data products. Not precisely wrong, roughly right. It's a journey. And with this approach, we literally took our set of workloads, going back to the 3 pillars, looked at the cost savings and the business value. We applied domain-driven design to those workloads to flesh out and formulate bounded context for those data products. And as a result, you see some examples there to the right of some of the data products that we produce. So we're up to 25 to 50 data products by doing this process. Remember, roughly right, then precisely wrong. They have a canonical model. With that canonical model, we can connect the data. Now, we do understand that we're going to have to make some performance considerations and trade-offs and loosen those bounded contexts, but it's okay. So lastly, I will leave you with what I started with. This is a journey. We're learning by doing, and we are evolving. So with that, I'm going to turn it over to Anu Jain, who's going to walk more into the technical details of the data mesh architecture.
Thank you, JR. So you heard about why we went to the data mesh architecture, and I'm going to talk a little bit about the blueprint of the data mesh architecture. I am, as a head of the data for the JP Morgan Chase Bank, one of the key critical area for us is focusing on the customer journey. We are focused on enhancing the quality of our customer with a personalized experience, ensuring that not only we are giving them a personalized experience, but we are creating a new risk strategies enhanced through AI and machine learning in public cloud. We are also looking for how do we enable our data consumption at a much faster and agile rate in the public cloud. To do all of that critical strategies which I talked about, think about the critical words I spoke. Connected customer experience, personalized customer experience, faster speed to market. For all of that, it's critical how you think about your data producers. Our mission is to empower our product teams to produce a highly trusted and secure data sets, not only for the consumption within their own domains, but outside of their domains. And as JR had mentioned, we had 450 plus petabytes of data. So think about our size and scale. Our data is growing every day. We have multiple data lakes and data warehouses, and it continues to grow. I'm sure several of you have also faced challenges in in operating a large-scale data lake, especially when you think about how it's organized today. So one of the key critical areas where you'll see a lot of organizations like ours are thinking about is how do you manage your lakes better, and that's where the data mesh design comes in play. So how do you start thinking about creating boundaries of logical separation from a producer side? And how do you start thinking about organizing in a much more presentation of the data from a consumer lens? Given the enormity of the scale of the data at JP Morgan, we wanted to store our data once, and we also wanted to free from the processing overheads which we have today. And for that, that's why we took the mesh design as an implementation of our lake. It's super, super important for you to think about what's your control boundary of a producer account, because that determines how you will operate and manage your mesh. So we looked at various options. One of the options we thought about was, should we have one producer account for our whole lake? That seems to be too large. Then we thought about, should we have one producer account per data product? And the third option which we looked at it was, should we have producer accounts by a line of business or a sub-line of business? And we opted for the third option because it kind of relates well into how our organization is designed today, and also it helps in the discovery of your data products. So when you think about data mesh design, JR talked about data products and data producers. I know it is an organizational challenge, it's a cultural challenge, but still it's critical for you to think about why do you need to have data products and data producers. Data producers, we specifically wanted our data producers to think really hard about their data and deliverables as data products. We wanted them to take ownership of their data and make the data much more meaningful for their data consumers. We really wanted them to think about the SLAs of the data that they produce and manage the SLAs for both completeness, freshness, and the quality of the data. They are responsible for managing the whole life cycle of the data, which starts from the data definitions, metadata, super, super important, classification, SLAs, retention, and destruction. Like any product, they should be responsible for the complete documentation of that data. And with that kind of model, it helps the data owners as well as your technology leaders to support the ever-changing governance control requirements which they have, and specifically to support our JP Morgan CDO community. With this kind of model, this was a huge benefit for our CDO organization because it to meet their compliance and as well as their sovereignty ask. We also did that because think from a consumer lens. We have all heard about that metric that how much time consumers spend in searching for the data. But with this kind of a model, our consumers can shop for the products, can request for new products, can also give feedback back to the owners on the kind of products they are creating. For a large and complex organization like ours, the data mesh design serves to enforce strong governance by providing a consumer-driven marketplace and where the interaction between the data producers, the products, and the consumers can be tightly controlled. So now I'll walk you through at a high level the blueprint of when I say producers, what do I mean by producer? When I say consumer, what I mean by a consumer. So foundation of a data mesh design establishes the access controls and intercommunication between three critical personas. Think about it. A data producer, a consumer, and a central hub. So here you see a producer. So what's a producer account? A producer account manages the procurement, the transformation, and the publication of the data. It is the responsible for ingesting the data, whether in a stream or a batch from your system of records, and also responsible for publishing the data and creating that multi-tenant environment within that account. These different tenants store the data in the same buckets. And you can see in the center, the buckets are raw and the trusted buckets. The bucket serves different purposes, and Each and every bucket has an associated pathing convention so that we can create that multi-tenant structure within the account. Now for processing the data, you can use services such as EMR or Glue, and ultimately the producers are responsible for ensuring that they are publishing their data in the catalog in the central hub. Now let's talk about the second account, which is the central governance account. As I had mentioned before, we chose one account for a line of business or a sub-line of business. This account is responsible for ensuring that the governing and enabling of the access to the data set. Chanu had talked about the lake formation tag-based approach. So we adopted that approach, and for us, in our design, a lake formation tag denotes a specific data product. So when you think about a data product will have all the databases and tables within the same lake formation tag. We also leverage the lake formation cross-account data sharing feature to enable that sharing of the data products with the consumers. And lastly, I forgot to move it. And lastly, think about the consumer accounts. The consumer accounts are responsible for enabling the analytical environments which the end users will use to access the data, and we allow our consumers to access the data using services such as Athena, SageMaker, EMR, and QuickSight. One of the model which you also see is the financial model. And when you think about the financial model, this kind of an architecture enables us to make sure that the producers are responsible for the cost of processing the data and storing the data, and consumers are responsible for the cost of consumption of the data, which is the analytic and the SQL queries. So this kind of model helps you to segregate the producer cost, the consumer cost, without duplicating the data as well as sharing the data. At a very high level, just to summarize, think about it. We wanted to create the autonomy and the empowerment on the producer accounts where they are responsible for the ownership and the process of it, and the lake formation is used for sharing of the data products. And now, how do you scale this architecture across your multiple line of business? To scale this architecture across the different lines of businesses, each and every producer account manages the data within their own producers, and central hub accounts are used to manage the discovery and the sharing of the data across the different consumers. And lastly, to summarize, we use this architecture to create the logical boundaries between the producers and the consumers, have a diversity of the topologies that scale for their organizations, and you can create as many of those producer accounts and consumer accounts as your size of your organization. Leverage the tags and the cross account for enabling the data sharing and enabling the integration with the rest of the AWS services. And with that, I'll call Chanu to close this out. And before Chanu says, we are hiring at JP Morgan, you can see the kind of work which you are doing. I'm going to have a shameless plug. Go and look at our careers. Thank you.